In this video, we're going to discuss a few exceptions to the octet rule. Now, we've already discussed one at length, which is hydrogen, and it's our most common exception to the octet rule, and that it follows what we call the duet rule, and it only wants to have 2 electrons around it. There's a few others too. Another exception that is less than the octet rule is elements in group 3A that can form covalent bonds. And really, that means boron. Boron is a metalloid and not a nonmetal, but it can participate in covalent bonds. And it will opt for 6 electrons rather than 8. And so it has 3 electrons in its valence shell, and it will opt to have 6 total electrons around it when it forms covalent bonds. And so you'll typically see structures like this one shown here of boron trifluoride, where it forms 3 bonds and then doesn't have an actual lone pair, like something like NH3 would, or PH3. Then we have exceptions to the octet rule that expand the octet rule, or elements that can have more than 8 electrons around it and when it covalently bonds. And there's actually a lot of these. Elements in the 3rd row are able to expand their octet, is what we call it. And the reason they can do this is because they have empty d orbitals, and our empty d orbitals are in the same shell as our valence electrons, but higher in energy. And so they are not filled. They won't be filled until we start filling things in the shell above it as the elements get larger and larger. And so these empty orbitals can actually accept electrons into them, which gives them this flexibility in covalent bonding. And there's a lot of elements that do this, but the ones that are the most common, especially in biology, are phosphorus and sulfur. And the structures that are typical are these phosphate structures and sulfate structures. And so we're looking here at phosphoric acid and sulfuric acid. And so these are common acids that we use in the lab, and you can see the phosphorus has 10 valence electrons around it. It has 5 bonds, each with 2 electrons. And this sulfur actually has 12. It has 6 bonds to it, each with 2 electrons. And this phosphate structure is probably the most familiar. If these hydrogens weren't there, you would see that phosphorus forms this polyatomic ion, phosphate, that really ends up being the backbone of DNA, part of the backbone of DNA. And so these are common structures that we'll see in nature. Within the scope of this course, you do not need to expect to draw something with an expanded octet unless you're instructed to. So stick with the octet rule for our purposes, but I would like you to be able to recognize and be aware that these structures exist, as you'll likely come across them.